Hello everyone. Today we are going to solve the 11th problem of the array. We have solved the 10th problem, and we have uploaded the solution of it also. Yeah, if you want to check out this GeekNerd ST, then you can click on the description. There is a link. You can click that and you will redirect to this page. Okay, so we are going to solve the 11th question. So without any delay, let's start it. Okay. Sorry, I clicked the wrong link. Okay, this is the next permutation problem. Okay, so next is let's read the question first. Given an array of integer ARR representing a permutation, implement the next permutation that rearrange the number into the lexicographically next greater permutation. If no such permutation exists, rearrange the number into the lowest possible order, sorted in the ascending order. A permutation of an array of integers refers to a specific rearrangement of its element in a sequence or linear order. Okay, let's read the example. Like here it is 2 4 1 7 5 0. So here it becomes 2 4 5 0 1 7. Okay, here like because it is the greater, and we the next one, the next, if we find the like every possible combination, like let's understand the question first. Okay. Actually in the question we have given a array. Okay, here we are given an array, so array can be like this. Okay, so we the permut what is the permutation? Permutation is rearranging the elements, right? So we'll find every possible rearrangement. Okay, let's hear that. Sorry, this is not that. Okay, so we can switch this place also. We can switch this place also. We can rearrange anything, like we can jumble all this number also. So let's have here, and I will put, sorry, I will put 0 here. So can do that also. So anything we can do that. Even also we can do like this also. Hmm. But out of every possible number, like let's have this also, right? Okay. Hmm. We have to find the next greatest permutation. Okay, let's have another example also. Here too. These are all the permutation of the given array. But what want? We want the next greatest permutation. Okay, so we have to find the greatest permutation first, right? So here, what is the number? Number is 2,41,750. Okay, here we have 24,000. Sorry, 2,41,705, which is lesser than this. So we'll discard this. Okay, we'll discard this. Oh. But here here we have 2,41,057. It is also lesser than the given array. Okay, given number. So we'll also discard this. Hmm. Then here 2,40,000. Here 40,000 became. Of course, it is lesser. So also we'll discard this type of permutation. Here here we have 2,41,750. So here we have 2,45,000. Uh, Here we have 41,000. Here we have 45,000. So it is a valid response. I will not say it is the answer of it, but it's a valid because it is greater. But what we want? We want a next greater permutation. Okay. Here we have 7,45,012. So it is greater than this. So it can be a valid response. Hmm? But we want the next greatest. So if we try to find every permutation, and at the end we'll get all the all the permutation, and we want to find the permutation which is greater than the given one, but lesser than the all other permutation, right? So the brute force approach will be like that, like we'll find every permutation and we'll calculate the value of it, and find if it is greater than the given one and lesser than the all permutation. Okay, but the brute force approach is very complex, and it's not worth to write the code also, because it will uh, take so much time. We have better solution than this. So what will be the better solution? Let's understand. So here it is the array. Okay, so what we are going to do here is uh, basically, suppose take an example, 1 comma 2 comma 3 is there. So basically it is in the increasing order, right? So if you try to find the next greatest number, we just have to make 1 comma 3 comma 2. Okay, let's find the permutation of it. Okay, it is the smaller number. We can find easily what are the permutation, right? So 1, let's fix 1, 3 comma 2. Hmm. Let's fix 2. So 3 comma 2 comma 1. Okay, sorry. Let's fix 3. So 1 comma 2 comma, sorry, 2 comma 1 comma 3. And there should be another, like if we fix 1 also, there are, okay, 1 fix it, 2 fix, then another permutation can be like okay, these are the all kind of permutation, I think. 1 is fixed, 2 3, 2 is fixed, okay, okay, 3 is fixed, okay, okay. So these are the all kind of permutation that we have for the given array. So given array is 1 comma 2 comma 3, right? So it is 123. Here it is 132. Okay, and here it is 321. Hmm, and here it is 213. Okay, so I want to find the next greater. So 132 is greater, 321 is greater, 213 is greater. As it is in the ascending order, every possible combination will be greater, right? So here the next greater will be 132, right? So why is that? Because as we should first think of changing the left portion of the number, because if we change any thing in the left, sorry, first sorry, I'll take my word. Actually first we have to think to change the right side of the number. Okay, so if we change the right side of the number, it is the lowest order, and it will find the greater number easily, right? So here if we change the 3 and 2, here we can become 32, right? So why it become greater? Because 3 is greater than 2. So if we switch the greater number with the small number, like if the 3 is in the right side and the 2 is the left side, the greater number is in the right side and the smaller number is in the left side. If we switch that, then only we'll get the greater number. Okay, but okay, it is a one kind of example. Okay, let's suppose I have 1 comma 2 comma 3 comma 4, not like this. Okay, let's have like this 3 2. Sorry, not like this. Okay, 4 3 2. Hmm, sorry, not this 3 4. Okay. Hmm. So let's have a number. So let's change this to 7 3 4 and here 1. Okay, if we go from the right, here 1 and 1 4, if we check 4 and 1, so 4 is greater, so no need to change. If we switch that, then it will be lesser number, right? So if we check 4 comma 3, 3 is lesser. If we switch that number now, so the number will be like 7 4 3 1. But it is greater than the given number that we have, but is it greater than the it is the next greatest permutation? No, it's not, because we have a we have a permutation which is 7413, which is much better than this one. So whenever we are switching a number, then we have to think that like that if like we are having the 4 here, so after every the like when we are having like this, we are switching 7 and 4, then after that the number are there, like after this number and this number should be in what we say in a increasing order, because uh, every number that came after it will be greater than the um, given number, because we have a greater number in the higher order. Okay, so after that what it comes, it will not matter that much. Okay, so first we have to think like which number should we switch here in the case. So if after that, like we have to sort this, so 1 comma 3 will should be there. Okay, so what are we going to do, we have to switch the number, and then we have to sort it. Okay, I think you get it, right? You got it. But I will choose this number and let's try, are we getting the correct number or not. So here, so here I will check 0 5. 5 is greater, left is greater, so move on. 7 5, 7 is greater, so left side is greater, move on. Then 1 7, the 1 is greater, so 7 is greater, right side is greater, then we can switch it. Okay, so let's 2 comma 4 comma 7. Okay, or here we will sort 1 5 0, we'll sort it, so here 0 comma 1 comma 5. So is it that number that we get in the answer? No, it's not. Why is that? Copy here, paste. So what's the difference here? Here the 5 and 7 are in the wrong position, because why is that? We are assuming that the one that we get, like when the 7 that we'll place it, we'll get the greater number, right? But the next greater should be greater than 1, but we can also switch 5 with 1, right? So we have to place a number that is greater than 1 in the highest order, the third order, in the third from the left side, but but we have to make sure that it is greater than 1 but smaller than the rest of the other number that are there in this component, in this area, or the right side of the 1. Are you getting it? Like we have to place a greater number in the right side, in any place in the right left side, sorry, left side, and after that we have to sort it, hmm, to get the greater number, right? But we got to know that like we can't have this, because these are in the decreasing order. If we place any number and we want to switch any number with the right side number, then it will become less, hmm? But we get a position where we can switch a number and sort the right side of it, and we'll get the greater number. Okay. But the thing is, the right side are the greater number than the 1, right? But what which number is the question? The problem here is which number should we switch? The thing is that we have to switch to that number which is greater than 1, just greater than 1. Okay, so how will do that? As it is in the decreasing order, we will go like this. Like we'll find, okay, 7. 7 is great. Is 7 is greater than 1? Yes, it is. So we can switch, but will not. Okay, we'll find, is the next number is greater than 1? Okay, 5. 5 is greater than 1. So we can switch. Okay, but we'll not switch. We'll check the next number also. Okay, next number is 0. Can we switch it? No, because 0 is lesser than 1. We need a number that is greater than 1. So the 5 is the good solution. So when we get 0, after that, if there is number, then that should be less than less, because it is the decreasing order, right? So what we are going to do, first we'll switch 7 with 1 with 5. Okay, 1. Okay, and then we are going to sort this number. Sort this number means 0, 1, 7. Okay, now we get the answer. So what are the steps that we are going to perform? First thing, we'll search from the right side onwards. We'll search like is it like, we'll search for the number that is um, lesser than the right side number, like as will go through the array from the right to left, and we'll find the right element should be greater than the left element. Okay, so as we'll iterate over here, and we get here the right element is greater than the left element. Okay, so then we'll stop. We get a pivot here. Okay, and then what we think, we'll go again from pivot element to the right, and insert that, like to find the next greater than the 1. So here we here get 7. Okay, it's a possible solution. Go next right. Then we'll get 5. It's a possible solution. Then go right. It's not a possible solution, so we'll stick with 5 and we'll switch it to 5 and 1, and the rest of it we will sort it. So after switching, okay, if you observe, I will say it, but I was thinking of saying it later, but okay, after switching 5 with 1 7, you can observe that it is still in the decreasing order. So instead of sorting it, we can reverse that also. So it will be the best optimized solution. Okay, so first we'll sort it and see whether it is working or not. Then we will reverse that also, because it is in the decreasing order. If we reverse it, then we'll get 0, 1, 7 also. Okay, so let's think before going to the code. Let's think of the edge case also. So what is the edge case? As we see, can the constraint is the size of the array can be 1 also. So if the array size equal to 1, then we'll just return it. Okay, because we will not need to have any like permutation, like it's the only one permutation, so we'll send as it is. Okay. Okay, it's the best case. And another case is for the if there is no possible next permutation. What does it means? It's the greatest number. So the number, if the number is in decreasing order, then we will sort the array in the ascending order. So okay, when we are doing the first step now, like we are checking like if the right element if is smaller than the left element, right? Then we'll continue, and when we get the left element is smaller, that means when we find there is a breakage in the decreasing order, then we will stop. But okay, but when we are if it suppose if it is in the decreasing order, then we'll not. Hmm. So if the number is in decreasing order, then with when we are iterating from for the first step, then it will not find any number that is the left number is smaller than the right number. Okay, so we'll not get the pivot, and at the end we will reach to -1. Then if when we reach to -1, then we'll going to sort it in ascending ascending order, or what we can do, like as it is in the decreasing order only, so we'll reverse it. Okay, so let's start coding. Okay, so first we have to take care of the edge case. That is, let's have n is equal to array dot length. Okay, if n equal to 1, then we are just going to return as it is, because we'll not find any permutation of it. Okay, then we will do the step 1. Okay, let's have step 1. What is the step 1? Finding the pivot. Okay. Okay, so what how to find it? Like we will iterate from int I is equal to, okay, as we want pivot also, so int let have I is pivot. Okay, so int I, okay, I is equal to 0, 0 nahi, n minus 1, I greater than equal to 0, I minus minus. Okay, and find if where we have to stop. We have to stop when, okay, we'll not start from n minus 2, because we have to check the right. So we first will check these two, then we have to check these two, then we have to check these two, and we'll get that like the left element is smaller than the right element, then only we have to stop. So here arr I is smaller than arr j, arr j ai plus 1, I plus 1, then we have to break. So here we get I as a pivot. Okay, after that the step is complete. But in the first step also, if we get I as a -1, then we will sort it or reverse it. So let's at first like we will sort it. Okay, so if I is equal to -1, then we'll erase dot sort. Okay, and we'll do this sort of the array. Okay, here the step 1 is complete. Step 2, we get a pivot element which on which element we will switch. So we have, in the second step, we have to find the possible number that we want to, the required number that we want to swap. Okay, so we can say like finding the number to swap with pivot element. Okay, so let's have int j to find, and j should be I plus 1 because we are finding from this right side of the, we are going to find in the right side of the yeah, the pivot element. Okay, so here we are going to int uh, okay, let's have like this. Okay, int j is equal to I plus 1, j less than n, j plus plus. Okay, if what is the condition of finding like possible number? Okay, is that the number should be greater than the pivot number but lesser than all. As we carry forward, we'll get lesser because the left side of the pivot element is in the decreasing order. So so yeah, it is the left side of the pivot is in the decreasing order. Okay, so we are going to have check whether the ARRJ is greater than ARRI. Okay, if it is the greater than the pivot element, we are going to switch. We are going to assign the pivot index, which is j. Sorry, we are switching the possible number index. Okay, so here j should be, okay, not j. Okay, the thing is, okay, when the condition breaks, when the condition breaks, will exit, then it will be better, right? When the condition breaks, we will break out of it and do j minus minus. It will be great, right? Suppose like here we'll check first, the pivot element is 1, right? So j is I plus 1, that is j is pointing to 7. It check whether like uh, whether the possible number is less than equal to the pivot element. It is not, so it will not break. Okay, then it will move to 0. No, sorry, it will move to 5. Sorry, I'm checking the wrong okay, wrong array. So we'll check 5. Is the 5 is smaller than equal to 1? No, it is not, so it will not break. Okay. And will then it proceed to 0, and as it is smaller than the 1, the pivot element, then it will break and will j minus minus, then we will pointing to the possible number. So after that we'll get the possible number to swap with the pivot element. Then we have to step 3 swap element. So int temp is equal to arri is equal to arrj, and arrj is equal to temp, which swapped the element. Okay, after swapping it, the step 4 will be the fourth step will be to sort the element that are there in the right side of the pivot element. Okay, let's sort the elements in the right side of pivot. Okay, so we can do like this: arrays dot sort ARR I plus 1 comma ARR dot length. Okay, basically it is taking the from which index you want to start, and the index up to the index minus 1. This array dot length minus 1, it will be sorted. Okay, so let's run it. Okay, this passed. Let's submit it. Okay, what is the problem? Index minus 1 out of the bond length. Okay, okay, after sorting it we have to return also, because we don't want to execute afterwards. Okay, so let's submit again. Because we get when we get decreasing order, we have to sort it and return it. Okay, done. Okay, but with we can instead of sorting the array, what we can do, we can reverse it, because the left right side of the pivot is also in the in the decreasing order. If we reverse it, it will become increasing order. We don't need to sort, because the time complexity of the sorting is n log n, due to which our programs time complexity is becoming n log n. Okay, we want to make it n. Okay, so we can have another method. Void, sorry, reverse. Okay, reverse ARR. Okay, like int. We'll have array from which index do you want to sort, and up to which index you want to sort. Okay, so the code will be like this. In I should be less than j. We have to sort the I with j. Algorithm. Then we are going to increase the I and decrease the j by 1, and until everything is reversed. Okay, and instead of sorting like this, let's comment out and we'll do reverse ARR. We have to do it completely, so 0 and length minus 1. First index and last index. Here also we can do reverse. Okay, reverse ARR. It is reverse ARR comma I plus 1 and the last index. N, I have assigned it n. Oh, I haven't. Okay, n actually, n. It is n. So n minus 1. Okay. Sorry. It is solved. I think you have understood what I have taught you. So if you have any doubt, then you can comment down below. And if you like the video, then like it. And if you have any feedback, then please mention it in the comments. So thank you, and meet you in the next question. Bye bye.